So yeah, today I'm going to talk about this data observability thing, and I'm going to talk about it as a best practice, right? So best practice that can be embraced by everyone, and I will give some example about how this can be introduced as a best practice for everyone. And I'm going to use a few examples that are going to be in Pandas, scikit-learn, PySpark, and dbt. If you don't know any of these tools, raise your hand, ask questions. I will be happy to give a kind of quick summary if I can make it properly about these different tools. All right. So yeah, maybe a few words, but Chester has done a great job introducing me. Just in a nutshell, who I am. So as I said, I'm in Belgium. I've been working for 20 years in data. I started as a, let's say, data miner, if you remember that name, right? So data miners, I was hardly involved into project involving data, especially with defense governments around the world. So I was managing project and working in project that was involving satellite and vector data. So essentially geospatial data. Where I was using mainly Java, but I was trying to introduce other language back then, like Python, R with the Fortran layer in the background. But also I started using Spark Scala at that moment. And then when I was kind of fed up using strict system, closed system, and non-open source system, or whatever was actually black box, working on large distributed systems that were hard to actually maintain, I decided to move in the area that I thought will be huge, which was named big data back then. And I was involved in the Spark community since 2010, basically almost when Spark has been created. And I created this Spark node thing that was created before Jupyter, when Jupyter was named IPython, right? And nowadays the project it's not active anymore because there are so many good notebooks out there that are dedicated to more than Spark and only Scala. But nevertheless, there are still people using it, and we have more than 3,000 people in there. And the last 5 years, I said I'm involved in Kensu. I'm not the CEO anymore because I had the pleasure to onboard a new CEO who is close to you, most of you, I would say. She's in the Valley, Eleanor, and because we have expanded our footprint also in the US now, and not only in Europe as we were doing in the last 4 years. And nowadays more on the product side as a CPO, Chief Product Officer, and that's why I'm happy to come back on stage in order to talk about this vision and this passion that I have for this topic. I'm a regular Odyssey author, so when I'm talking about this is because I'm currently writing the Fundamentals of Data Observability book with Odyssey. So it's the two first chapters available on the Kensu website or on the Odyssey platform if you have access to it. So these are still draft, right? But they're available, and I'm finishing currently the third chapter, which introduces different practice in order to introduce data observability in a book. So a lot about myself, sorry, but I wanted just to make sure that why I've been thinking about this kind of topics over the years. There is a reason, is because I've been struggling so much with data along my years that at some point I tried to work on something that was useful first for me or for people like me, and then it expanded pretty much like we did for the Spark notebook. I'm doing it now with data observability. So data observability, I will introduce it in 3 steps. First, I'm going to talk about it, right? Largely, I guess that you have been how to say, that you have heard about data observability in before, right? So maybe I will give an alternative definition to it, right? And I'm happy to discuss it. And it's largely discussed also in the book, but I'm here to also answer any questions. So I see, Christina Dong, you don't know any of these tools. So, okay, so I will introduce the different tools that I was talking about here, like Pandas, PySpark, scikit-learn, and also dbt, which is not mentioned here, which is the second step. And the third step is a short demo what it could be as a first step implementing data observability in your project. So first, what thing is it? Cool. When we define data observability, there is a kind of eagerness to jump directly in the topic and talk about what is data observability, but generally I prefer to talk about first observability. What is observability, right? And you will see afterwards why, because there is more than data observability to take into consideration in order to leverage data observability in a proper way. If we apply data observability alone, we miss a lot of opportunities that we basically lose a lot of opportunities in your visibility. So in IT, large sense, right? In information technology, in IT systems and teams, observability is really a capability of your system, so the whole system, infrastructure, architecture, software, whatever you have in mind, right? So it's really an ability, a capability that this system has to generate information. Right. So you have your system and this thing is generating information. So it's sending information about how it works. Right. So it's really like a car nowadays. It has sensor in the car in order to provide information about how the car is behaving, what it is, etc., etc. But now we're thinking about this kind of information flowing out from the system, such as IT systems, right? So it's really a capability that is embedded into the system. It's not something that you are addressing from the outside world. It's something that you're receiving from the inside world. In this case, the world is the IT system. And what way it's important to receive this information from the system is in order to be able to understand what's going on there, right? So you want to understand how the IT system is working. So you need this information to do it. Actually, observability is also what we do with data, right? So the world is generating information, right? So the data is flowing out. Let's say we digitalize them into data, and then we use the data in order to model the world and then learn from it, right? So basically, we want to understand the state of the world in a way. So there is a lot of relationship with what we do already, but we have to put ourselves in the meta world in a way, right? In the observability of a system which is generating value in this case. So what's important is that when you want to interpret the state of a system, right, you cannot interact with it, right? It's like in chemical systems, right? So if you want to understand how your chemical sample is actually behaving, right? You cannot actually probe it, you cannot touch it, you cannot do anything. Otherwise, you change the whole thing. That means that you can only receive information by looking at it, by receiving information sent by the system itself. So in this case, it's the same thing. The observer that is receiving information cannot go into the system and check a few more information. Otherwise, it's not anymore observability. It has an incidence on the state potentially. It's also important because by having this kind of observability embedded into your system, right, that doesn't require the observer to go into the system to check what's going on, right? But still having the capacity to understand what is the state of the system, right? You can turn this person into a software also, right? Because basically there is no manual action or human action anymore, right? Because there is no manual action or human action, you can replace this kind of capability of understanding the state of the system by, well, we are part of the data team and the ecosystem, by an application that will use the data in order to generate prediction about the state today, inference, and tomorrow predictions, right? But observability, as I said, is a global system, right? So we have observability in what I explained in the book, right? In 6 areas, but it's a definition of my own, right? So I have built over the years, there's a framework where we have observability in 6 different areas. First, we want to have an observability about the infrastructure, how the machines are working, basically. Then we have the observability that is applied at the application level, which is what we call software observability, right? So how the applications are working in the infrastructure. And you can see that the areas here of infrastructure and application are overlapping. Why? Because the application are running in infrastructure, right? So in order to understand the state of the application, information about infrastructure is important. And conversely, in order to know why an infrastructure is working in a certain way, information about which application are running on this system is also important, right? So you cannot work independently in order to have the full context of the behavior and the status. But that's not only the two things that you need to consider, right? Then you grow, your system is also have to consider also, the security part, for instance, right? So the system can differ in its status because some security aspect has changed, right? So it may be hackers, but it may be also governance policies that have changed that actually have an influence on both infrastructure and applications. Next area, there is the user and purpose, right? So you want to understand who is using the system for what purpose in order to understand why an application has actually a behavior that is different from yesterday. Maybe the user has used it in a different way, right? So having information about this, right, will also create a lot of visibility into the state of the system later on. There is also analytics of observability, understanding what kind of analytics are being performed, right? So this is where a machine learning stands, right? So this is where data transformation, machine learning, and stuff like that are actually happening, right? So it's almost similar to application here, but here we're really concentrating on learning system, which are separated here from applications. And finally, we have data observability, where we want to have visibility, a capability of the data to generate information, observation in this case, about its behavior. But everything is mixed, right? Everything is intersecting. And by having this kind of framework, right, having information generated about the different areas and having this information crossing each other, right, in order to be able to rebuild the world, right? This is how you get visibility about the internal state, right? Because you have as many, I will say the word, features like in machine learning, right? So you will have enough features about how the world is behaving to be able to infer and later on predict the state of this system, right? So a lot of information, a lot of introduction, but it's really important, right? Because actually when you see this, that is why I cannot really easily, right, or almost impossible for me, define data observability on its own, right? Because there is so much interaction between data observability and the rest of the system observability, right? And doing data observability alone, right, that means that you will lose so much context, right? So much context by not considering the fact that data observability is crossing a lot of these areas, right? Maybe not all observations are necessary, right? But there is a kind of core information that is mandatory to have in order to understand why at some point in time the data is behaving in a certain way, right? So basically, this is what data observability, and to be honest, this is not something that is new, right? So observability has been there for quite some time now, and we're lucky because over the years, of course, software, platform, infrastructure, applications, everything has scaled nowadays. For the last 5 years, 6 years, data and data teams have scaled like crazy, right? That means that every time we have scaled on something, we had to introduce observability in order to gain some visibility about what has been done by these scaling teams, right? So you'll have, for instance, observability generated infrastructure by using something like the syslog, right? Or information like top and root that are generated by the infrastructure in order to understand how things are working. Application, we have, of course, all the logging and the log4j and logging in Python or whatever you have in mind in your system. Even software like BI software have a lot of logs in order to generate visibility about what happens there. And there is also recently the open tracing and telemetry, which are two framework, let's say, that are kind of standardizing the way application observability can be applied in the applications. For the security, we have a lot of information coming from the traces and the secret logs, whatever you are, like an IAM or something like that. There is a lot of information there. We have also a lot of observability that have been introduced in the past in anything that is being used by users, right? So we have, of course, audit logs, which is a typical one, but we can also use something like git blame in order to understand what happened. So who has introduced something new into an application, for instance. This is highly relevant also to understand what's happening. But of course, when you see history of a Tableau workbook, for instance, right, this is where it's also very interesting to have this information. But for data analytics, I'm combining both together because they're really close to each other in this case. So what kind of information may be available already, right? Or what information are we missing in order to gain this visibility? And how can we cross this information with the others to make sure that we are not creating something that is totally outside of context of how the data is going to be used and how the analytics is going to be applied. So in order to understand what kind of observations can be generated, and if I make a pause, notice that I'm talking about observations, right? So because data observability, but observations is also the word that we use in AI or machine learning, right? Whatever you call it, right? So this is the word that we're using in order to represent a row in the feature tables, right? So in the feature matrix, so an observation is the entry, right? Same thing, because here we were observing the word and then we want to run a machine learning algorithm. Here we are observing the internal state, and later on we want to be able to apply also machine learning on this information in order to predict the systems. So what kind of observations do we need? And in order to answer these questions, I will first list a few questions, right, that we are regularly asking ourselves where we are addressing, let's say, data issues, right? Because where a data observability shines, of course, and observability in general, is when we have an issue, right? We want to understand the state quickly, as quickly as possible, in order to be able to find a solution in the shortest time possible, right? So what are the type of questions that we are asking ourselves regularly, right? I have a few ones. First, I'm to doing a bit. Don't hesitate to raise your hand or ask questions, or maybe shout out if you have a concern or an alternative to what I just said. So the common questions that we are generally struggling with when we are handling some data system. First, when there is an issue, when there is something going wrong with the data, right? So the first information that we are generally willing to have is, how is the data used, right? So you have your, let's say, your pipeline, which is generating the customer table in the data warehouse, right? And at some point, the customer information is kind of fishy because you have some dashboard that are presenting weird numbers, like the number of customers has dropped dramatically, right? So basically, there's something fishy, right? But this different information I just given, right? So data warehouse, dashboard, drop of the customers are example of how the data is being used, right? And without this information, you don't know exactly what kind of issue you have to solve, right? Because the data can be used in so many different fashion, right? When there is an issue, you need first to understand what kind of issue, what kind of problems in which context are happening, right? Without that, you're just going to generate to try to solve a combinatorial problem, which is the data quality without any information. So how the data is being used is a big topic, right? So you want to understand what kind of users, what are the purposes and stuff like that, right? So this is the kind of information you want to have. And this kind of information, so I will, the third column is a channel. So how can you get this kind of information, right? So how the data is being used is part of one information, which is called the lineage. So I guess that you have some notion of lineage, right? The lineage is the connection between some input and some output, right? So how the data is being used or generated or read, right? Written, right? So the lineage is the connection that exists between data. So by having this information, you have a notion of how the data is being used, of course, right? And this can be part of the lineage, or you can, of course, have some information, the logs, like you have your application where you do some SQL, and then at the same time you generate some logs that, okay, now I'm generating a table for the data warehouse that consists in the customer data, for instance. So this is information about what you're doing. So this is information that you want to have access, the information that you want to have access to really quickly when you have an issue, because basically you have little time to respond, as you know. The second question that we generally ask ourselves is, when we have someone that comes to you, like generally it's the stakeholders or the data users, the business users, or the data governance, data quality, who knows, right? So when do you have this kind of people that are coming to data analytics people or data engineers people, right? So they ask, hey, my data is wrong. Can you fix it, please? Right. So this is just like the kind of discussion that you have, not more of information generally. So the first thing that we're asking ourselves, and we ask to that person who generally is pretty upset, right? We say, okay, but why do you think it's wrong, right? So what's wrong there? What should it be, right? What are your expectations, right? So you want to know what were the expectations before they were using it, and nowadays when they have an issue with it, apparently, what were their expectations, right? About performance, quality, availability, whatever you have in mind, right? So what were the expectations? So that I can work towards those expectations. I want actually try to make sure that these expectations are now fulfilled, right? You generally don't have this information. Now it's time to generate visibility on that. And this is where I'm going to talk about rules later on. So what are the rules that we can set on the data in order to understand what are the expectations or shared expectations about the data? Where is the data? So when we have an issue with the data, sometimes we have to find out where the data is, right? So sometimes we have easily the access to the first data, right? So we know that this table in the data warehouse is a problem, and then we have to find out where all the data sets are, where they're coming from, etc. So they're generally taking a lot of time in order to understand where the data is. And this is where logs are really important, right? So when you have a data transformation or whatsoever happening, logging where the data is read from and written to, right, is really useful when you will have to understand the system status later on. What does the data represent? So that's another question also that we ask ourselves, because when we have a data issue again, maybe we were not part of the project back then, but we are now responsible for managing it or maintaining it, or it was like 6 months ago or a year ago, so we don't have anymore, the model in mind, right? So that means that we generally want to ask, okay, but what kind of data do we have here? So what is, again, the definition of that thing, right? So what was the different type of information that I have in this data, and what should they be, right? So this is where the structure of the data is important, the metadata, right? When we have information about the fields, the types, and the change, of course, in these things. And this information can be propagated through the logs, right? So this is also something that we can easily generate ourselves. So I'm almost there. So now there is also something very important, is the metrics, right? So when we have something with the data that we want, and we want to address the issue very fast, right? So we want to know what is the data looking like, right? So what does it look like? So how many rows? What is the distribution of this and this column, right? Or what is the pattern of generation of this data, etc., etc. So many different things you want to know about this data in order to understand it, right? So you need to understand it in order to be able to understand the problem. You need first to understand the data. To understand the data, you need to have information about the data. And this is where content metadata, so this is different from structure metadata. Content metadata, where I'm talking about metrics and KPIs, are very important. And the channel to distribute this information, it is called metrics, actually, in observability. Not only you want to know what the data look like nowadays, but you want to know also what it would looking like before, right? Because it gives you information about how it has moved and changed over time, right? And this is how you can detect potentially the causes of the issues, right? Because some data has changed dramatically between two timestamps. This is what we call also data drift, right? So having this kind of information about what has changed in the last run or updates of the data, right, is important. And this is where historical metadata is important, right? Not only you want to have what is the data looking like nowadays, like the structure and the content, but you want also the historical metadata that you can have in both the logs and the metrics. And finally, the two last questions that we are generally asking ourselves is, okay, now I have the problem in this data, so I recognize it, I understand it, I know the expectations, right? So I understand what has apparently changed in the data in the last period, but how the heck is this data being created, right? So what is creating this data? So what were the data being used in order to generate the data? Because it may be there that I had already an issue, right? So you want to understand that. So this is where data lineage is the observation that we need. And this is the channel that we're going to use, the lineage. And finally, we want to know how the data is being created, right? It's not only like how the data are linked to each other, right? So to navigate throughout the lineage, as we say, but we want to know which application, which Python code, which Spark code, which I don't know, notebook, which data dashboard, whatever has created this specific data, right? Because at some point, what you will have to fix is not the data. What you will have to fix is a application, whatever that is, that will actually restore the data as it should be, right? So we need to know where are the applications that were part of the data lineage. This is what I call the application data lineage, right? Because these are the things in between data sources in the lineage. And this is actually something that you will get in the lineage and the logs too. So I will pause a second, right? Because these are the questions that they take actually days, weeks, months, I don't know how long they take generally when you have an issue in order to find answers, right? So this is why we want to have these answers as fast as possible. I will pause a bit, and I see Chester has activated this video because of a question by Andrew Smith, isn't it?
Yeah, the Andrew Smith has a question. So if I understand correctly, observability is the extension and the sophistication of the old log files that a program generates. Is this a problem generating a more informative log files, or how do you read the log files? So can you address that?
So yes, and yes. So yes, indeed. So observability in large sense is generating log information, right? And indeed, so here the problem is, how do we generate the right information in the logs, right? And therefore, afterwards, how the heck are we going to read that log in order to make useful, right? And this is successful of problems that we may generate if we don't think properly at the beginning. If we start generating a blob of logs, without any structure, without any anticipated use case in mind, etc., right? It's basically like data, right? If we don't model the data, we're gonna end up in weird situation where we cannot do anything with the data because there is no model, right? So in this case, it's the same thing. So how do we generate the right data? And what is the model that can be used in order to make sure that afterwards, the data generated in the logs can be used appropriately? Does that answer correctly the question, Andrew, or anyone else? Does this scale without limit? No, I'm trying to understand really what you mean by what should be scaling. The amount of information generated, maybe.
Yeah, Andrew, if you post your question or directly just unmute yourself and directly ask questions. Oh, the mic doesn't work. I guess he's using the log analogy, basically say, well, if you generate so much data in a log and how that going to be scale. I think it's not a log is just in this case is a metaphor. It's not going to be one log file. It's going to be a lot of metrics stored somewhere, either the tables or some other things that you can parse.
So
Hello.
In a way, yes, and then it was refined here. So does informative data. Sorry?
Can you hear me?
Yes.
Oh, okay. I have a quick question, follow up on what Andrew was asking. This is Christina. What does the other analytics tools like T4C, a Glassbox play in this? Because you're talking about the channel, all of that's log files. Of where does that play in here?
The which tool were you mentioning?
Analytics tool, a lot of those.
Analytics tools, right?
Yeah.
So
like Glassbox, like T4C, all of that stuff, platform.
So the platform, right? Okay. So like the data analytics tool like Tableau or Click or
yeah.
right?
Tableau is one of them too.
Yeah, exactly. So this is where we have a use. So generally what they do is abstracting out what we do with the data, right? So basically what they do is that they generate this information, they generate a lot of things in the background, right? That means that these tools needs to embrace also data observability, right? They need to support a user like they support a user with what they do with the data, right? If you want to support your user properly, you also support them by providing visibility of what you do, right? This is how a good tool is structured, right? So this is why actually over time, and it's happening, right? These tools are embracing more and more data observability by generating more and more visibility, right? Of course, you cannot expect everyone to go at the same speed and to understand how it should be done equally, right? So this is why you can also build, and I can touch this a little bit later on too, you can build system that will generate information by actually squeezing an agent directly in the platform, right? So you extend the platform with this capability of generating information. But basically, high-level tools have to embrace this over time in order to generate information, because otherwise it will never work. There is a chapter on that. There is a section on this specific question actually in the chapter I'm delivering probably mid-September in chapter 3, where I'm discussing. So what you talk about is basically what I call low code, no code. Right, low code, no code. So what do we do in this case, right? And I'm addressing this specific question in a few pages. Thanks a lot, Christina, for the questions. And
hey, Andy, question. A great point regarding writing a lot of data into log files to the point that all this data becomes humongous. So we've seen a similar issue where we're writing whenever we see a system exception, we write it into the Delta log file. And then the plan was to use any tool, say Azure Log Analytics or anything like that, to go through the data. Would you recommend an approach where every system log exception is written to Delta? Or like if you are designing such thing, would it be like a critical failures or like an expect type of failures would be written?
Yeah, definitely. So maybe I will dig into that later on, right? But these are all good questions because I'm going to talk a bit more about them later on, right? So the question is, so we have this kind of log system that is handling the exceptions, right? Not expectation, exceptions, right? And the idea would be actually to introduce some information about the viability or the reliability of the data as exception, right? This is actually one of the best practice that I'm visualizing nowadays. So if you know what are the expectations on the data, if you're reading the data and you're using the H column in the data, and you know that this data cannot be null, right? Otherwise, you will have problems, or your users will be sad if the data is going to be null, right? You know this expectation, so you can actually apply a rule on the data you're reading, and then if they are not matching your expectations, you can actually raise an exception. And this is what I'm talking rule, basically. Does that complement your remark and question?
Yep. I just wanted to know whether we are doing the right thing. So it sounds like we are doing it right.
Okay, yeah. Awesome. So I will cover that a bit later, right? So I will show you a few things that can be done in order to introduce this, right? And again, the third chapter of the book, again, so it's available for free on the Kensu website. So you can go there, register, and you will have the PDF. So I'm not trying to buy you the book yet, right? But the third chapter is actually addressing this set of best practices and how to introduce data observability in the system. So in order to complement with whatever other observability you have already in place, like exception handling. So just to summarize, right? So if we have to subdefine, let's say the data observability is one of the components of an observable system, right? You have an observable system, so it has data observability. If it's capable of generating information about how the data is influencing the system, right? And the other way around. If you know how the data influences, I don't know, the application, infrastructure, security, whatever, right? Or conversely, if you know what is the impact of changing infrastructure or infrastructure issues on the data, then you have a data observable system also, right? So that's a component, right? So without the conversely here, and actually this, right, you lose a lot of possibilities, you lose a lot of power when it comes to efficiency at dealing with, whatever we deal with data nowadays, which is generally issues and the speed to production. So as a summary, in order to generate this kind of visibility, we have logs, we have metrics, and we have traces. And here I've listed a few data that we can introduce in these different channels, right? So I'm talking about logs, metrics, and traces. Why? Because we have nowadays also, it's sad, but we're also how we can aggregate that, right? We have systems like for logs, we have things like Datadog, and then we have metrics like Prometheus, right? And then we have traces like Dynatrace or whatever, right? So these are different tools that we have that are captating, different types of channel of information, right? And actually, in order to make it this information relevant and easy to use and contextual, right? It's important to be able to merge them, right? This is related to the question of Andrew, right? So how do we use the logs then, right? So if you're not able to use the log, it's useless to generate them, right? So we need to be conscientious first on how we generate the logs. Otherwise, in the logs and metrics and traces, in order to make sure that we can leverage it later on without too much burden. In this case, we need the model. So before digging the second section, so it's already 45. Chester, do I have a kind of a time limit? When should I stop? When should I stop?
Well, you can continue. Continue. I think until 1.
Until 1, so 15 minutes.
Yeah.
Okay, cool. Okay, so because I want to show you also what it looks like. So let's take an example where we have a small pipeline, right? And we want to make it observable, right? So this is just an example, right? And this example is on a GitHub account that I will show you after, right? You can run it by your own, right? So let's say that we are using dumps of data of SAP somewhere. Boom, we have the orders, it's a CSV. We have the customer information, it's also a CSV. And this data are this CSV file dumped by the open source, the operational sources are in the data lake, and then they are used. So there is no data warehouse here for simplicity. They are used directly in 2 different pipelines. One is directly training a model, which is in scikit-learn and pandas, right? Which generates a pickle file, which is the model, and then this model is used in the prediction Python file, which is also pandas and scikit-learn based, that generate the result CSV that is capable of generating prediction about the orders, right? Then we have the other pipeline, which is generating a view in dbt, right? So for that, we have several scripts. One that is loading a certain, we'll call it a data warehouse, but it's more like a couple of database here, tables, right? So the loading Python file in pandas will take it, and then we will create the sources. And then we have 2 script models in dbt, right, that will generate 2 views. One is a data mart where we have a consolidation of the orders and customers, and then we have finally the view that is needed by the user-defined user, the stakeholders that will be used by the analytics, I would say, in Tableau, as we said earlier, in ClickView, right? So for simplicity, I've kept something that I can show easily here. So here we have dbt and we have as an engine, we have Spark, but it could be anything, right? It can be a Postgres directly, it can be BigQuery, it can be whatever you want, right? But this is the pipeline that you have in the GitHub account if you want to try by your own. So there is something, if you want to introduce data observability in this pipeline, there is an anti-pattern that we know already, which I call the Kraken, right? The Kraken is this thing here, this external platform, right, that we call nowadays sometimes observability, but for me it's not observability. It's just something that will disrupt and destruct over time your architecture infrastructure. This is an external thing, which is going and scanning and reading the data, like here, right? So like the arms of the octopus, of the Kraken, right? So these things are actually scheduling metric computation, lineage or whatever, in order to create some kind of visibility about the data. That means that you need to schedule them, you need to create a specific set of resources, reserve a certain set of resources for this kind of external computation thing to read the data, compute some information, metadata, metrics, lineage, whatsoever, and then aggregate information, right? So why is the Kraken? Because actually it goes all over the places, so it's super intrusive in all places. You need to activate all security outbound connections, so this thing has to access to everything. It needs to contain all the credentials of all the different access to the folders, the database, the data warehouse, the BI tools and stuff like that, right? In order to create the visibility. What it means is that first, it creates a lot of mental efforts because you need to always know which data source to scan and to detect and to monitor and to schedule metrics and what we call harvesting jobs in order to consolidate the data, right? It takes a lot of resource, a lot of time, right? And a lot of money, basically. Also, you have to dedicate this resource that I was talking about, right? So, which is basically computing information. So this thing is going to cost a lot. And however, at the same time, it generates, like, if I would be a hacker, I would love you guys to deploy such a system, because I know that I have to go through this platform and I have access to all the security information that will allow me to go wherever I want if I'm good enough in the system of data, because it's like a security gate, basically. It's like a small door, very weak, in the back of a very beefy, castle in a way, right? But if you crack that door, you're in. So basically, this is the Kraken pattern. It doesn't work, right? So this is what we tried to do in the last 3 or 4 decades, at least since I've been working for the last 20 years, sorry. This is what we tried to do, never worked, right? Tried multiple times, doesn't work, right? The other way around is what I call at the source, right? So where is the source of data usage and data creation? This is always an application. Might that be the Python code, the Spark, the dbt, or the Tableau, or the Click, or whatever tools we were mentioning earlier. These are the things that are generating and using data, right? So they are at the source of the observations, right? And these are also the things that we will have to manage to change when there will be an issue, right? We don't create data, we create applications that create data. That's very important to understand, right? And to have in mind. I'm always struggling with this, where I hear that data analysts and data engineers are creating data. No, they are creating applications that create data, right? An engineer that builds a bread machine don't create bread, it creates a bread machine, right? So it's not the same thing, right? So basically, in order to have all access to all this information, we can do something a bit smarter, right? A bit more involving also, right? Which is having computation of the metrics, the lineage and everything at the application level, right? In order to distribute the role, the responsibility, and also the computation and the resource consumption, right? At the time where the data is already available, right? Again, even tools like Tableau, etc., can also embrace that because they are applications, right? So by having this kind of computation of the metrics, the metadata, the location, etc., the security information, everything can be propagated by the application. And instead of having this external observer right here, computing everything, they can access to the aggregation of the information flowing in. Again, I'm just explaining logs here, right? But here we're talking about logs that talks, contains information about data instead, right? From within the applications. What's also important and interesting with the data observability at the source pattern, right, is that not only you know what kind of data exists and what are the metrics and everything, right, but you know what are the applications using the data and producing the data. That means that because each application will have their own set of rules, their own set of expectations about the data, because it's of course the case that each application here will see the data differently, right? They will have a different usage. They will have a different need from the data, even if the data is the same, right? So that means that each application can introduce their own expectations at their own level and not generally, right? Instead of setting rules and expectations on the data file, you can set rules about the order CSV at the application level instead, right? So you can have more specific contextualized observations and pre and post conditions, as I call in the book again, right? So that means that the data is flowing. This is the notion of the source. I hope it was clear, right? So what are the different advantages, right? By distributing the resources, avoiding having this kind of security gate here, because basically there is no security stored here whatsoever, because this thing is never accessing any of the data. The information about this data is flowing in. Only the observations, only the metrics, only the metadata. So how do you do this? So 6 minutes. So I'm not going to have time to introduce the visual. So I'll try to be quick, right? So for the developer, so this will be addressing the message more to the developer, because actually I cannot show the code within Tableau. I can show something about Tableau, but here I didn't anticipated it. But let's talk about what we can do in Pandas. What do we need to do in Pandas? And again, this is in the GitHub account repository that I will show after. So imagine that we have this code which is reading CSV file and loading them into into customer Postgres table and so forth, right? What do we need to generate in terms of visibility? What does the application know when it runs? It knows what are the inputs. In this case, it knows that it's consuming the customer list CSV in the campaign folder. It knows that it's writing into the customer table in the Postgres table, Postgres database, right? Same thing for others, but it knows also the links that exist between the input and the output. This is known by the application, right? This information can be actually generated and being logged, right? And how you can do this, right? So there is this, here is a shout out, right? So we have this open source, I'm enforcing this message, right? It's an open source Python library that is extending the Pandas and many different other Python libraries, in this case Python, that is extending the libraries, not replacing them, extending them in order to generate the visibility, right? So what you're gonna do, you're gonna create here first you will have a logger, like in any system, is like logging in Python. Then you introduce the interceptor, so you want to intercept this information directly at the application level. Then because this thing has been extended, when you read and when you write, the interceptor of Pandas will automatically capture information that says, oh, the file is over there. This is the schema of the file, because it's a data frame, right? So we know the schema. And here are the description information. By using describe, this library can generate the describe information, package the metrics, and send them to the data observability platform, right? In the logs first, right? So this is what can be retrieved automatically using these two functions. And then, of course, because there is a connection between the two variables, there is the lineage that can be extracted from the code also, right? Again, the application knows everything, so it's good that we can use a different set of strategies in order to generate a lot of observation by design. right? Which is the cool thing. By design, it's already there as long as you introduce the right agent, as we've done in IT observability or software observability in the last decade, I would say. So when we talk about Spark and DBT, which is using Spark as the engine in this case, right? So if we have a application like this, which is rating information in the CSV again, and then we do some filtering, we do some aggregation, and then at the end, we write into different files, right? So we have also multiple information that needs to be generated. So what is the Spark application? This would be another information that is interesting to have. But what are the inputs? What are the two outputs? What are the filters? What are the computations, the aggregations in this case? And what are also the projections, the selection, right? This information is over there. And again, because we have connections between these things, so this is the lineage part that is composed in the code. So what you can do also is to use another agent similar to that, right? Which we take the code, take the behavior of the code, right, and generate observation about what it does. You have the logger, you have the interceptor, so this is a agent, and then this thing is going to extract plenty of information from the DAG. If you know Spark, right, so the Spark has a notion of DAG, which is holding all the computation that will be executed against the cluster. And this is what is leveraged here in order to extract the data source being used and written, the schema, of course, the lineage, and also even the metrics. So computing some metrics about the information read and written. So I'm accelerating a little bit because it's 59. So scikit-learn, machine learning, same thing. We're going to use a pandas to read. So we have the input at the end. We have a scikit-learn in the middle, linear regression, which is using this input in order to train the model that is being dumped here as pickle, right? We have some transformations such as projection here. We have a filter that is applied because we had to train the data. Of course, we have to create the trained data set and the test data set. So we have a filter and we have a transformation in this case, which is part of the analytics observation that is transforming this data using the model and creates a model as an output. And of course, we have a lineage between inputs and outputs. And again, here, by having the logger and the interceptors, right, you will automatically get information, observation about the read information and the dumped written information, such as where the data is, where the data is written, what are the metrics, and even for models, also model metrics, right? So not only statistics or whatsoever, but also model metrics. Because we have the capacity within the code to generate this information easily, right? And this is what should be embraced by, as I said, and will be embraced over time by these high-level tools, right? Scikit-learn, again, so this is just the prediction part. So we train the data, now we predict the data. We have the inputs, we have the output, which is the prediction. We have some selection and we have some transformation, which is the prediction. And then we have the computation that is added to the final result, and then we have the output that is written. So we have the same thing here. So I'm accelerating, as I said. So with the logger interceptor extraction that is automated by design, by default, applied to the code, right? Excuse me again. So this is the prediction, and I should actually show you what it would look like in the platform. So what it would look like when you have generated these logs and structured, right? So in the book, I'm talking about what is the model that you can use. I mean, the JSON or whatever encoding you use, but what is the model you can use in order to leverage all this information in a platform, right? And this is where I should go there. So what I'm going to do is I will do it very quickly. So I just have this sandbox where you can go also, as long as you have currently a Google account, you can log in to it. So it's a free of charge, right? So you can log here into the sandbox. And what I've done is that I already executed these scripts, right? So I have my marketing application that I have here. It's my project where I have my data load Python, my DBT that is creating the data mart, and my result at the end, which has an error at the moment, right? There is a rule that has failed, and we have the training and the prediction here. So these are the different transformations that we have. and very quickly to show you what could be done with the structured information, the logs aggregated at the application level, at the platform level, right, by the observer. In this case, this is the platform, right? We could have the lineage at the application level. So what is doing this application, creating connection between this data source, and we quickly, when we have an issue, like here, we have an issue because one of the rules that we have set into our problem, in our project, like a precondition, is like, if data is not good, then throw an exception. This is exactly what you could do if you want to use this thing, right? And I can show here that we have an issue because we have way too many rows for the phone column, right? And because we have this thing here, what we can use by, what we can do by leveraging the metrics, the data source information, the lineage, the metadata, the schema, and everything, we can build this kind of a view across applications, even across project if you want, right? Which allow you to browse the problem, right? Here, I can select the phone, the rows, which has a problem in the moment, right? And what I can do, I can check what was looking like the DBT output here. So I have also 185, and I can follow the process by taking a look here, what was looking the customer table here. I have also 190, no, I have 69 now, so there is something going fishy here, probably, right? So I may have a problem in this application, which is, if I remember well, this one. So this is showing only the application that I have selected, which is the orders and customers. So if I have a problem, apparently it's over there. So I went very fast on this thing because I just wanted to show what can be built in terms of visuals, right? And yes, and I will take this question, or not, yes, it's a question. So from Sandeep, it looks like the feature of Databricks data live table where the quality requirements can be coded. So in a way, yes, right? So because basically Databricks is built on top of Spark, so they are building rules at the Spark level, right? So in a way, yes, but you take this philosophy and you extend it to everything, including the dashboard, including the data preparation, including the data ingestion, including whatever you have in mind. That's a philosophy. That's a best practice. Like, we always check the input of a web service before using it. We should be checking the data before using it and before delivering it also. This is my role today, and my task, right, for today is to explain that this is a best practice that everyone can embrace by applying certain things into their code, right? While they're developing it, while they have everything in their brain, not later on. They have everything in the brain, all the rules, all the corner cases, or whatever can be coded in the code, using the logs, using the rules, and then you can sleep like a baby when you deploy in production.
This is actually pretty cool. I know we're out of time, but I do want to ask a question because I built something similar to this, but not in this level. I like the idea that, you directly put this thing at the beginning when you're coding, in a sense, like the rest of the code looks like the same, but you embedded the lineage directly into the code. But the one things I noticed, like you can easily get some basic metrics out of it. But in GoPro, when we did it, was we had a separate, like another task in the pipeline to calculate the quality metrics. There has a lot of rules. Essentially, this column have to this, and we build all kind of even regular expressions to combine several rules for each row of the data, and then give you a risk score. Say, hey, this data is below, whatever the score, and then if they pass, failed, and then aggregating the whole table, say, hey, this this column for this table is actually risky or whatever based on the risk score. So I don't see a place that you can put these kind of user-defined roles.
There is a problem. I mean, there is maybe a problem that you have faced, but let me check this to show you this. Right, sorry, too many animations. Maybe I will just take it as simple as possible, right? So the thing is, the rules that you have applied, right? So you were saying user-defined rules.
Yes.
Right?
Yes.
That means that you're not considering those rules as producers ones. Do you?
Maybe when I say rules, these rules are the user who knows that. Like, for example, this value must be greater than 100, for example. They know that. And you know, so you replace that if my value is, you know, beyond that value, I'm seeing my data quality is wrong. So, yeah.
Yeah, exactly. So I'm talking about this in chapter 3.2 and a little bit in chapter 2, right? The thing is, they know that, but as data engineer, we should know it too.
Yeah. So basically, they define the rule. We provide them to define the rule, and then we run the pipeline to calculate the, you know, say, hey, this column is like a 90% of violated rule, or just like 1 or 2 rows of violated rules. So you can give a score. So that was basically. I'm asking if you're using the framework you're using, where I specify that kind of rules.
So basically what would happen, right? So let me see if I can draw that thing. Where is it? I don't, where, I mean, it's over there. So basically what happens right here, so what you say, which I saw very often, right? So basically the user is the person who is using this data, right?
Yeah.
Say, oh, actually I have this rule, right? Because I'm going to do this one. Right. Yeah. And oh, actually, I am going to also, I have another user and I have another rule for the other because I'm going to build this thing. Right. That means that you have 2 different set of rules because you have 2 different users. Right. Right.
And not quite. So it's not so much of, basically it's that before you user do the training, they basically want to make sure the data quality is correct. So like, for example, the price of the something cannot be negative, for example. That's a rule, right? So it's a data quality rule before you get to the training part. So that should be universal rather than defined by you know, whoever doing the training or loading. So it's a kind of a data quality thing. So before, you know, the pipeline.
But the main issue with data quality, which I face over the years, is that actually data quality is hardly applied on a data source level because everybody will have a different sense of the quality because they will have a different usage, right? Generally, they will have different way of perceiving the quality of the data. It's pretty much like a smartphone. You will estimate the quality of your smartphone depending on how you're going to use it, right? So if you generate rules, you will have to generate rules that are generic for everybody, which will not fit the needs of everybody in a way.
I see.
So this is where you can fine tune. I don't say that you cannot do data quality generically, right? There are a few things that are very well defined you can apply, but then you need to consider what is the specific usage and specific rules that they want to apply, right? And if these rules are defined without visibility of the producer, when they fail, they are going to be responsible of fixing them, right? But they don't understand the rules. They have no idea what the rules are, right? So they first have to understand if the rules is correct, if there is not a problem with the rule, if there is not a problem with the computation whatsoever. It takes a lot of time, right, taking defenses before they start looking at the issue. And then only will take, you know, this is why I'm talking about shift lefting. Okay, they can define the rule, right? But they need, when they validate it, they are improved, right? They need to actually shift left towards the people who are generating the data in order to apply the rule on their own, right? This is what I'm talking about. You want to know too. You want to understand. You don't know. You don't want to know. You want to understand, actually. So this is something that needs to be applied. And this is collaboration. This is discussion. This is not a tool. No? This is just purely communication. Does that make sense?
Yeah, totally. Yeah.
Awesome.
I know we're 10 minutes over. So, but this is a good stuff. And thank you so much for presenting this from all the way from the high level theory all the way to demo the actual demo with your product. Yeah, thank you so much, Andy.
Thanks a lot to you for organizing everything, and I hope that the lunch went well for people in the US and you enjoyed it. And there's a question maybe I can answer real quick from Andrew, who asks about the multi-agent systems. Yeah, yes, basically you can go so for the Kensu. So most of the Kensu agents are open source, by the way. So we have Python, R, Spark, Flink, DBT, Airflow. Java. We have many different stuff there. Tableau.
So Christine was asking whether you can share the slides.
I will, sure. Yeah.
Okay, cool. All right. Thank you so much, Andy. Thank you for everybody to joining. I know there's a lot of people coming from Canada, New Zealand, and other places. Thank you all. We'll see you next time.
Thanks a lot, everyone. Have a great one. Cheers.
Okay, bye.
Thank you so much. You guys are the best.
Okay, thank you. Bye-bye.